In this section, I'm going to be talking about logistic regression. Now, according to Wikipedia, logistic regression is a statistical model that, in its basic form, uses a logistic function to model a binary dependent variable. Now, when it comes to logistic regression, it's also known as logit regression, maximum entropy classification, or the log linear classifier. As you can see from the figure, logistic regression is a form of regression where the target variable, in this case, what you're trying to predict is binary. It's either a 0 or 1. Where in our past lectures with linear regression, that value can exceed 0 and 1. So if you're a researcher and you're trying to develop a model to predict whether a patient rejects a kidney transplant, logistic regression can be useful. The logistic regression models the probability based on the values of one or more predictors. Mathematically, we have a nice function whereby pi hat of x are values for predicted probabilities of the response for certain values of x sub 1 all the way to x sub p predictors. And of course, parameter estimators b sub 1 also all the way to b sub p, whereby they're estimates of regression parameters that maximize the likelihood of obtaining the observed 0 and 1 values. Logistic regression is used in many fields, including machine learning and social sciences, and of course, most medical fields. So it's very important to understand. So what better way to do it than use an example? So I'm going to go ahead and copy and paste some code. And as you can see from the first few lines, I'm going to import the necessary libraries, load my diabetes dataset from the Pima Indians Diabetes Database, which we've used before. And below I've provided the link to it. So I'm going to first read my CSV file into my diabetes data frame, split the data into training and test sets with a 75-25% split. And the last part, construct a logistic model using the training set. And again, in this example, I'm going to be looking at my two variables that I've used before, BMI and glucose, and create my logistic model that will help me create a sigmoid function. Awesome. So let's try to run this. And right off the bat, we can see over here an intercept, minus 7.5, BMI 0.08, glucose 0.03. Now these values again are my regression parameter estimators. For my predictors, in this case, BMI and glucose are going to be my predictors. Therefore, the logistic model that classifies a person whether or not they have diabetes is given by the following mathematical form. So for fun, if we attempt to demonstrate this logistic model with a three-dimension colored surface, we should have a shape that looks like this. So I'm going to go ahead and copy and paste my code to plot a 3D surface. And here's my function, which is the following logistic model. So I'm going to go ahead and run. And this is what it looks like. BMI, glucose, and the outcome. This is awesome. We're able to visualize the logistic model in 3 dimensions based on my glucose and BMI predictors. Now in the next section, what I would like to do is run the model on the test set that I split prior, make predictions on the test set, whether someone has diabetes or not, and then finally plot it in 3 dimensions for visualization purposes. It sounds complex, but it's actually pretty easy to do. So I'm going to show you an alternate way of building the logistic model. So I'm gonna go ahead and copy and paste my code here, whereby I'm building my logistic model based off of my predictors, my BMI and glucose, to predict an outcome whether or not someone has diabetes. So we're gonna go ahead and run this. And now the next part, I'm gonna go ahead and copy and paste some code, whereby I'm going to create a 3D surface based off of my logistic model over here. And here's the fun part, going to plot my test set for glucose BMI and see where my predictions end up. Outstanding. So as you can see here, this is my logistics model, and these data points are the predicted probabilities of the response for BMI values and glucose values. So as you can see here, the higher the level of glucose, it is predicted that the individual will more likely have diabetes. And as a note, the fold where you see here in yellow, that is my cutoff point between glucose and BMI, whereby patients with predicted probabilities below a half can be classified as non-diabetic, and predicted probabilities with a value higher than that cutoff point of a half are classified as diabetic. As an FYI, it was determined that this classifier was about 78% of the time correct, which I'll show how to calculate in my next lecture. This concludes our section on logistic regression.